Hi and welcome to Prototype. We'll be solving the problem for LeetCode 589 N-ary tree preorder traversal. This is another problem in the LeetCode 75 study plan. Let's get to it. So given the root of an N-ary tree, return the preorder traversal of its nodes values. N-ary tree input serialization is represented in their level order traversal. Each group of children is separated by the null values. And it says see the example. So let's do that. We are given the tree with the root node with value 1, and that has the child nodes 3 to 4 in left to right order. And the first child with the value 3 has children in order 5 and 6. Okay. And it wants us to come up with the output 1, 3, 5, 6, 2, 4. And if we're looking at this, then the order is left and depth first. Okay, so we visit 1, and then we visit 3, and then we visit 5, and then 6, and then 2, and 4. So this is a depth first search, left to right. All right. We could do this recursively or iteratively. Let's do the recursive first. I do think it's slightly more simple, I guess. Initialize our output array. Let's call it result, and then we'll use a little helper function called DFS, and we'll DFS on a node. And if the node is null, then we can just return. Otherwise, we want to push the node's value if it's not null. And we will also need to call DFS on the child node. So for const child of node.children, DFS child. And at the very end, we will, we need to return result at the end for our DFS. And at the very end, then we can return DFS of the root. Alternatively, if we didn't want to do this, we could also just return, we could call DFS on the root, and then return the result. That also works. Well, let's do that. Submit it. Okay, so apparently it beats 91%. Now, could also, if we didn't want to call DFS first and just return the DFS call, just as a quick aside, we could do this. So return DFS root, and instead of just returning nothing, we return an empty array in the case where the node is null. And then also we return the result here. And since the result would be an empty initialized empty array, we could also just say return the result. So this would also work. Slightly less lines of code, but okay. Iteratively, to do a depth first search, we will need to create our own stack. The reason why the recursion method here works well is because we leverage the function call stack. But if we do this iteratively, then we'll need our own stack. But anyway, let's just set up the same thing. So let's say const result at the very end, such as an iterative solution, and just return the result. And create a stack. What's going to go in our stack? Well, it's going to be the root node. So we can just initialize the stack within root node, and then while the stack length is greater than 0, so while there's some nodes left to be visited, then we will continue adding children to the stack, and then continue to visit nodes in the stack. Okay. So the first node is going to be popped off. In the first iteration, this is the root node, and the first thing it wants us to do is to add the visited node to value. So we'll do that. And then what do we have to do? Then we have to add its children into the stack. So let's do a regular for loop. Okay. So for let I equal 0, I less than node children.length, I plus plus. We are going to, let's just say child is equal to node.children of I. Okay, we are going to, and if child actually, then stack.push child. Okay, so again, in the first iteration, we will pop off the root node and then we will add its value to the result. Okay, and now follow me here. But we have these children, it's 3, 2, and 4, right? And then we're going to push child 3 and then push child 2 and then push child 4. So what is the stack right now? The stack has the nodes 3, 2, and 4. Okay, end the first loop. Now what happens? Now we're going to pop off the stack, which is 3, 2, 4. When we call pop, it's the last element in the array that we're using to simulate a stack, or right? And then so okay, we pop off 4, and then we're going to push 4 into our result, and then visit 4's children. 4 doesn't have any children. Okay, and then we're going to do this again. Okay, we pop off 2, and then we check for 2's children, doesn't have any, and then we'd finally do 3. But wait a second, at this point you're thinking, that's not what we want. Somehow we've, what have we done? We've gone from 1 and then visited 4, checked if 4 had any children, and then gone back up and then visited 2. Right, so we've done depth first search, but right to left. So how do we fix that? We need to for loop the other way. So instead of left to right, we need to for loop right to left. And this is because we're using a stack as our mechanism to hold the nodes that need to be visited. Okay, and because of a stack, they're like a stack of pancakes. We take the pancake that we put on last, we eat that first. Okay, so let's run it. Okay, and will this work without issue? You think I need to also check if the root is null. Yeah, okay. So submit. Okay, and of course, go to LeetCode. So this time the submission is 32%. Let's just try submitting it one more time. See if you can get a slightly better result. 77%. So again, go to LeetCode for you. All right, so that is the solution with recursion and iteratively for N-ary tree preorder traversal, LeetCode question 589. Subscribe to see more. We'll be doing the rest of the LeetCode 75 study plan questions in short order. Thank you and see you next time.